Hello. Uh, yeah, that's good. What's up? Make sure that everything's working good. Okay, cool. So I haven't shaved, so forgive all this. But I can't really grow a beard, so this is what I'm left with. Um, but it's all good. So what's on the agenda today? Well, we finished. I think I'm done like playing around with the stencil buffer stuff for now, at least. I can't really think of any more examples to do that aren't. Well, you can do a lot with the stencil buffer, but the other things you can do with it are a little bit more involved. Like you can do things like, um, oops. You can do like constructive, what do you call it? Solid geometry. Let's pull it up in the wiki. This would be like a dream project to work on, where you can create these meshes from Boolean operations, but you can use the stencil buffer to do that. But the algorithms involved are a little complex, and there's not really a whole lot of documentation on it. It's all like, in these programs where you have to read through like probably C++ code and stuff. Like there's a lot of programs that support it, but to do it yourself seems like a pretty big undertaking. This WOMP thing's really cool if you've never heard of WOMP. They use, I don't know if WOMP does it with stencils or if they use like sign distance functions. But if you've never heard of WOMP, it's pretty cool. You should check it out. Yeah, where's the... I just want like a picture of their interface, but it's for creating 3D models and stuff. But you can do this constructive solid geometry, and they have like primitives for all that stuff. Anyway, oops, that was a preview of where we're going. But anyway, yeah, the whole point of that is that the stencil buffer is kind of done for now. You can do constructive solid geometry, that would be cool to look at, and you can do like shadow volumes and stuff, but again, like all those projects would be a little bit too in-depth, unless I wanted to do like a couple of streams on how to implement those things, but it would require a lot more research. So I guess it's time to jump over to a new part of the project, and I have this render targets example here, which I don't really think shows off very well like what a render target is. And of course, like part of that problem in that is that there's not a whole lot of like text here explaining what it is. It just kind of assumes, I guess, that you're going to jump into the source code of this. Yeah, and this is hosted. Make sure that this... Oh, I am signed in. I thought I was in a private window. But I guess there's nothing here that would be too, like, illuminating. But you can go to this. This thing is hosted, so I'll drop it in the chat. If you want to take a look at the stencil buffer examples, I think it's at stencil. Let's just go there. Yeah, it's just at stencil. Made two cool examples on that, but I think I want to jump over to this render target thing and clean it up. Not clean it up, but make it a little more interesting. This kind of example is a little bit boring in my opinion. So the thought that I had was this render target thing is just like a texture that you can put on anything. And the idea is that you would render some scene onto that texture and then use it as a map for a material. And that's what's happening here in the source code. Oh, I haven't even been showing my screen the whole time. Whoops. Yeah, so here's the example here. Yeah, so again, you can create your own scene, you can render to a target, and then you can use that target's texture as a input into one of the materials. So if we jump over to this application, in the render loop, you set the render target, you render to that render target. Well, first thing you do is hide this square mesh thing so that you're not rendering that as well. And then you make it visible again, and then you render the whole scene. This mesh here is set up in such a way that the material uses the render target's texture as a map. And that way, we render the whole scene and then we just apply it like a map. Or, we just apply its texture to the mesh. And that's the same thing that kind of happens when you render to the canvas. You're just applying that texture to the canvas. So the renderer has its own, I don't know if this is 100% true, but you can kind of think of a renderer having like a default render target. And that's what happens when you set this to null here. Reset use null as the first argument. Yeah, frame buffer meeting the canvas. So if you set it to null, you're gonna render back to the canvas. But this is the example, and I think we could do better than this. So the thought that I had was, why don't we render to, in everyday world or whatever, you think about things that have like moving pictures, like a movie or a TV screen or video games or whatever, they all have a screen, and then you can render to that screen. So I found this 3D model online. It's from this website. So these are all free to use as long as you give credit where credit is due. But this thing has a lot of assets and resources that you can use. And in one of these asset packs, here, I'll put that in the chat. One of these asset packs is like a furniture set. And in this furniture set, there's a TV somewhere in here. There's two kinds of, right here, there's a couple of monitors. Like you can see the little laptop and then TV. This TV thing is what you're seeing here. So I've already loaded it in this GLTF viewer, which is a pretty good resource as well if you are messing around with GLTF files. But what I want to do is replace this white screen with a render target. But I think for now, for today's stream, I want to mess around with getting the webcam to show myself on that little TV screen. And you can do that in Three.js. Let me pull up an example here. So here's an example that, takes your webcam feed or stream and then applies it as a video texture onto these surfaces here. So it's kind of the same idea. Well, it is the same idea. We're going to use a video stream, use it as a video texture, and then we're going to take out this. This is actually two separate meshes. I'll show you that when we load this model in code. We'll take out this white mesh and we're going to replace it with a other mesh that has the same size as this and positioned in the same location and is using that video texture as a map. And that way, if we do it all correctly, you should see what you see in the bottom right corner down here where I'm at. You should see that displayed on the screen in the actual like 3D world that we're gonna create. Once we do that, the next step is, okay, I think that's pretty cool. I just want to play around with that. Where does the render target come in? Well, instead of rendering the video texture, the video stream, we'll create like it's our own separate scene. We'll put some objects in there. Might even put webcam stuff in there, whatever. We'll just create our own little world, render to a render target, and then use that target's texture as the screen texture here. That might happen today, or it might happen next stream. But I think today we can get as far as putting the video texture on the screen here. Oops. Okay, so let's get rid of some of this. So I've already got this GLTF file downloaded and put in the public directory all the way out here under GLTFs. This tv.glb, that is this file here, or this model here. But I guess before we do all that, I have this under TV/app, and then let's go to Playground. I still have Playground. Oh, this is the deployed website. We need to load the localhost. Oh, it's under, hold on. It's under docs. I don't remember where this is located. Let's see, content, docs. Oh, it's under test. Let's rename it to Playground. There. Now we should be able to go to Playground and some runtime stuff, unknown content collection error. Oh, I think this is why I had to make a separate page for this. Okay, let's restore that page. That was source pages. Here, I don't want this. And then, oh, I need to get the server back up and running. Okay. And then that was the example from the other day, but we can bring in the thing that we're going to work on today. So that's located under miscellaneous, and then this is render targets TV. I think that's it. Yeah, okay. So let's create our canvas. This is the same thing that we always do. I mean, one of these days I'll move this into its own helper function because there's a lot of boilerplate here. We're gonna make an attachment. In that attachment, we'll make a renderer. Let me turn the music up just a tad. I think that's fine. Okay, so renderer, and then we need to make sure that we properly dispose of this. That. Oh, this needs attach. Okay. Now let's make the renderer loop. Put that in a promise, because we'll clean that up as well when we dispose. Renderer dot set animation loop. And then what do we do here? We just render scene with the camera, which these aren't made yet, but we'll make them. So when we go to dispose of this or do the cleanup, we want to do promise.then. When that resolves, we'll set the render target, or not render target, the animation loop to null. And we will, we'll just return that. And we wait for it. Or we return the promise. If you didn't know, anything that you put in here is automatically wrapped in a promise. I did not know that, but you don't have to return a promise here, because it will automatically wrap it, which is really weird. And this is even constant, so this shouldn't be a number. It should be promise of 100, but I think TypeScript always errs on the side of like generality. Can I get away with that? No. Oh, I can, but it doesn't like. I think something to do with the way it's parsing this. But anyway, this returns a promise, so we're just going to return it. Once that promise is done, that's when we'll do our disposal. Like that. And probably need a better name for this. Maybe like set animation loop promise. Kind of wordy, but that's what it is. Okay, so in this constructor of the renderer, we need to pass in the canvas, and then we'll just say anti-alias is true. Okay, now it's a little too loud. Okay, that's good. Well, maybe a little bit more. Let me adjust some stuff here real quick. Get back to the code. Okay, good enough. Alright, so don't have this scene or camera, and I'm surprised it's not telling us that this isn't defined. But let's make those. So we'll make scene, and we'll make camera, new perspective. Sometimes the LSP can get behind. This, I'm going to give it a class aspect square, so it's always as tall as it is wide. And then the last thing we do in this render loop is if we resized the renderer, then we'll get the aspect ratio, and we'll set that to the camera's aspect ratio. So ratio, or we'll call it aspect, is canvas.client width. Set camera aspect. And we'll pass in the camera, and we'll pass in the aspect. So that's like all the boilerplate That typically happens with setting up this like these little demos. But I gotta think of a way to make this a little bit simpler. But not right now. So we'll do that. I'll do that off stream probably. Okay, so what do we need to do is load the GLTF model or file. Module link. So we only need one loader, so put it up here in the module block. That's new GLTF loader. I guess that's fine. Got our loader. We need the path to that file. So that's the tb gltf URL. And then we have a base URL, so the way that you do that in Astro is like this. And then, because it's in public, we can absolutely, like we can use absolute paths. Like it's gltf's tb.glb. So glb is a binary file, and then gltf is like a JSON file. But you can load either gltf or glb with this thing. Let's do that. We'll load it. So that's going to be gltf loader.load async. This is the URL. We have that in a variable there, and then this returns a promise. So let's await it. And it'll give us a gltf back, but we need to add that to the scene. So we'll do scene.add. And then the way that these GLTF files are set up is that there's always like a top level scene, and that is an entry point into the whole model. So you'll typically just add that. Yeah, it's grouped, so it groups everything under one like parent object. We'll add that to the scene. But let's pull the camera back a little bit. And then this is a really small model, so I'm not going to pull it back very much. See if we see it here. Oh, and it's got standard materials on it, so it probably is in the scene, but we can't see it because we don't have any lights in the scene. Let me put this. Oh, you can barely see it there. Yeah, but let's put some lighting in the scene so that it's easier to look at. So I'm just going to steal that from a different example. Let's do a cube map. So I'll grab all this, put it up here. This is the cube loader. Gotta import that from GPU. Let's call this cube map files. Alright, then we load it down below. Let's let's see, it was cube loader.load async, and then cube. How did we load this? Oh, we just passed in files, so cube map files. But this also needs, oh it does. Okay, so we have it, like the base of the path has already been attached. And once that's done, we'll set the scene's environment and its background to that texture. And then also be careful and we'll dispose of it properly. Okay, there we go. We have lighting and we have a background. And let's make it so we can control the camera. So let's do orbit. Orbit controls from add-ons. And I also have another helper function or attachment for doing this. Pull that in. This needs the camera. Now we should be able to rotate around. So yeah. Okay, so let's take a look at this GLTF scene in the console. This is where it's going to get a little bit tricky because the GLTF itself, like the scene, it's not strongly typed. So there's a reason behind that is that, you know, you could pass this. It's kind of like taking input from a form. You want to validate it or parse it, or you can just assume that it's correct. These ligma trees. Don't. Is this a joke to say these nuts or something? I'm not gonna say. I'm not gonna say it. Yeah, I know better. I wasn't. I mean, I know that one. I know ligma and I know sugma or whatever. That's an old one. What was I doing? See what you did? You made me get off topic. It's okay. Yeah, so let's take a look at... Oh, I'm going to... I have this example here for render targets, which isn't very exciting. So this guy here, it doesn't really give you an idea of like what's capable with render targets. So the next thing I want to do is make an example that's a little bit simpler, a little bit more interesting. So I want to put myself, this webcam feed, which you see here, onto this screen here. And then once we do that, the render target thing is we're going to actually make a separate scene and then render that to a render target and then use that render target's texture as what you see on the TV screen here. But right now we have the GLTF model loaded. That's what this is, a GLTF model. We have it in the scene and we have an environment mapping so we get some colors or we get some lighting in the scene. We can see here if I don't do that, it's just blank. Oops. Like you can see it in there, but there's no lighting in the scene, so you can't really tell what's going on. Mm-hmm. Yeah, it looks like good luck, something fun, you know what I mean? Like... Yeah, putting myself on the tiny screen, so this example here will give you kind of an idea of where we're going. So this puts myself on all these little screens that are around this cube. But you can use a video texture and you can put yourself on that texture. So this would be cool to actually do something with this too. It's a little trippy though. But imagine like you have separate like video on all these screens. No. Yeah. Let's see, get rid of that. Yeah, too much, Josh. I guess before I do this, before we like take a look into the internals of this model, let's actually make it so that we can capture the video stream. So I'm going to do that in an attachment. And you need an actual video, like a video, what do you call these? Elements? And then I'm going to steal the code from that. I should have not got rid of it. but that example. So if you're ever like curious about these Three.js examples, they link you to the source code down here. And I did not know this until yesterday, but this is how you get a video stream from like a camera device within the browser. So I'm not gonna worry about like checking if they have a camera attached. I'm just gonna assume that it's attached. Or like their like navigator has access to these media devices. So we'll grab this code here, media devices, get the user media. What does this return? A promise. So we'll call .then on it. And is this a stream? Oh, let's see, what's it not like? Oh, you have to pass in constraints. So these constraints are, as far as I know, oh, something got messed up on this side. Yeah. What happened to my thingy here? This is the problem when you type everything or you use a keyboard for everything, is that everything has like hidden. I wish you could disable all of your like key maps. Like, don't let my program come with default key maps, because if I'm like a keyboard user for everything and I accidentally hit, you know, the keys and it does something where it messes up your camera like this, I didn't intend for that to happen. So it probably had something to do with loading the camera on this on the in the browser as well. But how do I get this so it's not clipping? We're gonna do this. We're just gonna roll with it. Oh, a little weird, but that's okay. I don't really care if people. The idea is to look at the code, right? Not to look at me. What were we? So let's get the constraints going. I'm just gonna pass this in line. So a set of video constraints. In their example here, they've got the width and the height. This is, you know, the width and the height of the actual. Yeah, if there's 100 of me, it'll be hard to not see me. Width and height of the like video stream, and then the facing mode, this user thing. This is interesting. You can provide, like, if you have a device like an iPhone, or actually all like camera phones these days have front and back cameras. So you can specify what camera you want to use. And I don't know why they didn't call this like front or back, but user means use the front camera. So on like a phone, you know, use the front camera of the phone. You would specify that with facing user. But the video here, yeah, let's just use 1280 for now. 720 facing mode. Okay, see you soon. And then let's see, is it cool with that? Oh, this needs to be an object. And this is the width. Just like that. So this gives us back a stream. And what you can do with that stream is set the video. We have this video down here. So this is a promise. So let's not .then it here. Let's take it over here. And when this video element is ready to go, that's when we will set its source object to that stream. stream. We have to do this in a dot then. So you could await it here, but I try not to do like awaits and stuff in attachments. Because otherwise you'd have to put async here. And I don't think async functions are something that you can pass into an attachment. So we'll just do stream here, that's all the same, but we'll wait for this stream promise to resolve. Let's put it in a variable, and then we'll do stream promise dot then get out the stream. That's where we'll set this like that. And there we go. And then we'll just immediately play it. So whenever I load this page now, it should, yeah, that video thing there. Yeah, there you go. So what we can do now is use this. Yeah, I think what it's doing, because you can see how it shifted the camera. And I think it might be because of that width and height or something, this thing here. So this wasn't planned for, but I'm just gonna roll with it. You can see me in this camera here. If we scroll down a bit, eventually you'll see me here. So this will be a little bit wonky for now, but I don't want to mess around with it. I'd rather just get on with the coding. Okay, so let's make a video texture. That you get from this. Video texture comes with 3. And it needs a video. We have that here. So now we have the video texture. Maybe just to see that this thing can be put in the screen or in the 3D scene down here. Let's make a mesh for it. Okay, we got our plane geometry. This is where the like width and height come into play. So let's just do 16 by 9 on this. And I think that's what this is too, by a factor of 80. So if you take this and you divide it by 16, I believe you get 80 out. Yeah, so let's have a factor, we'll call it 80, and then instead of doing this, that way we can do, this is factor times the width, and this is factor times the height. Then when we create that plane geometry, we can just pass in the width and the height here. But we're not, oh, this is geometry, so geometry. Pass that in. And then we need a material that uses this video texture as a map. So let's make that separately as well. New mesh basic. So that should be good. Let's see. Need to import these. And we'll pass in the material. So now we have a plane with this video texture on it. Let's add it to the scene. But I'm going to move it to the right just a little bit. Yeah, we got to bring that in too. So now we should see it. Yeah, look how big it is. Look how small that 3D model, that TV model is. But here it's in the scene. So we got 3 of me now. How many are we gonna have? I mean, I'll hide this one. And well, I don't know the class to do this. I think it's just hidden. Yeah. But I guess if you hide it, you don't get a video stream or something. Oh, and yeah, the other thing we need to do, the good thing this warns us, is set the color space here. So let's see. When you make the video texture, okay, we'll steal this line. Oh, and we didn't import the name, we just import it like this. Nice. So this little mesh, or not mesh, this TV thing is very tiny. But even if you did, yeah, so this thing should be 16 by 9 like units in this, I don't know, in this like world units. So you can see that it is very small. It's like less than 1 unit. But we need to get the size of this plane geometry, this plane mesh, this video that I'm on, to be the same size. Either we can size up this TV, or we can size down the video mesh. So I think what I want to do is size the texture, the video texture, to match the TV. That way we're only resizing one thing. This GLTF scene is actually a bunch of things inside of it. And I don't want to mess around with... Well, I guess I could resize the group itself, but I think it would be easier if we just resize the video texture. Maybe look at the scene, it's really just a group, and then it has children on it. This is the same thing with all like Three.js objects. They have children and they have parents. If they don't have a parent, then it's null, but typically like the topmost parent will be the scene itself. But yeah, you see this all over the place. This is like a scene graph kind of thing. But it has 2 meshes in here, and the first mesh is the like frame of the TV, or the like gray part of it, and then the second part is the actual screen. So just to prove that, we can get these things. You can traverse the scene. Actually, you can get by object name. And this mesh here, it's funny to see this video. I'm just gonna leave the video on there. I think it's funny. But look how stretched out it is. This mesh has its own name right here. So we can look for that. Yeah, just a render texture. I don't know how it's done internally, but I think it might, what do you call it? If we look at the video texture docs, it inherits some texture, so it's, I don't know, there's a separate render texture. But I bet if you look at the source code of this, or the actual like GPU stuff, or where it's calling like GL functions and things, or maybe Wigzel functions, it's probably doing like something related to that. But that's pretty obscure, like it's pretty obfuscated code. Or not obfuscated, but like pretty heavily abstracted. Get rid of this so I don't keep clicking it. This thing has a unique name, so let's grab the name. And I'll put it in a variable, we'll call that screen mesh name. Oh. How do I copy this? That way we can get it. So this could return undefined because it may not find that screen mesh name. Imagine like if this file changed, um, and the names of these things changed. Well, at runtime, it doesn't know any better. So to be safe, it'd say, well, maybe I found it or maybe I didn't. Like this is the same idea with finding objects in an array. You know, if you do like this, could return undefined. How do you do this? Yeah, I don't know. One of the LSPs is broken or something. But because this can return undefined, you probably want to check that you got something. So all these, this is an object 3D. So we know that this is going to be a mesh, but to be safe, let's create a guard function, is mesh. So a mesh is just an object 3D with a geometry and a material. But all these 3JS objects have like on the like class instance, it has a, I'll show you in a second here. So this could be anything. But we want to return the fact that m is mesh. And the way that we do that is we just say m dot is mesh. So if you look at mesh in the 3JS docs, it has this is mesh boolean here. This is always true, and it says it's read-only, but it's not actually only read-only. It's just a property of the class. And this isn't even static, so it's not, it's like every one of these meshes will have its own is mesh. Yeah, it's not good. I wish this just returned null. Like, why do we have undefined? And the way that I treat it is you should never really be touching undefined. Null is for users and undefined is for like, you know, weird cases where things, because even if you did like, this will, like calling this returns undefined. Or I guess void in this case, but void is assignable to undefined. But I think a good rule of thumb is just don't touch undefined. Don't like check for if things are equal to it. Don't set things equal to it. Just use null. So here, if it's undefined, if we can't find it, we'll just return null. And then before we do this is mesh check, we'll just check that it is not null. So an easy way to do that is if it is null, then we know something is totally wrong, and we'll just throw an error. We'll just assume that, you know, we can't handle this. And just for sake of demonstration, I'll just do it like that. So we'll say, couldn't find screen mesh with name. What is the name here? Just couldn't find the screen mesh with this name. Maybe the name has changed. If we did find it, we found something, but we don't know it's a mesh, or the runtime doesn't know that it's a mesh. All it knows is that it's something in the scene. Could be a camera, could be a mesh, could be just some object, like dummy object, we don't know. But we'll narrow it down here. We'll say if is mesh screen mesh. Now we know we're good, but same thing. If that's not true, then we'll just immediately throw an error. And we'll stop what we're doing, and we'll just let the like the error, like in Astro and Svelte and stuff, you can have these error routes, or you can have like recoverable errors and stuff. That's kind of off topic, but I'm just gonna throw an error. Screen mesh is not an instance of mesh. So now if you take a look at screen mesh here, it should be, oh, it's never. Let's see. Why is this null? Oh, if it's equal to null. I got that backwards. So now if you take a look at it here, yeah, it's a mesh. So we can actually set the visibility of this mesh to false. And if we take a look at it in the code here, or in the scene, let's hide the video texture too for a moment. But you can see we just took out the screen. Sometimes it has to be done, yeah. That's very easy to get off topic. Because you're like, oh, look at this cool thing, I want to show you this, but that's going to take like 10 or 15 minutes to explain, and you go down these like rabbit holes and stuff. But I always feel like I can't assume that people know, where all these things are coming from. So I just kind of assume that, they're just oblivious to these things. Not like in a mean kind of way, but, this might be the first time you're coming across these concepts. So I guess, like, a good thing to do is just say, if you're interested in that thing, here's a resource, in your free time, you can go check it out yourself. But yeah, we took out that mesh. Or we didn't take it out of the scene, we just set its visibility to false. Or like so that it wouldn't get rendered. But the like frame or this backside and this like stand and stuff is still being rendered. But what we need to do now is set the size of this plane geometry and its position to where that video, or not video texture, but where that screen mesh is. Yeah, I always like those things. Yeah, it's like supplemental resources and stuff. Yeah, I try to do that in these blog posts. Not on this, well, yeah, this website has some examples, I believe, like some further reading stuff. I'm not sure exactly which. Yeah, resources here. So I'll probably do the same in this demonstration. And this website, it's a work in progress, but it definitely needs, it's like definitely time to go in and fill out some of the, like a little bit more drier stuff, like yeah, every time I load this route, it does something with the texture, with the video. I was gonna leave it like that. Let's see, so so we need to get the size and the position of that screen mesh. And if you take a look at this screen mesh, let's log it out. It's gonna have a buffer geometry, or a geometry buffer. The attributes here, typical stuff. This is like on every 3JS, buffer geometry. You got your normals, your position, where is it at in the scene, and you got your UV for texture mapping and stuff. But we need the position, but this is an indexed geometry. So it's going to reuse, I think when they created this in like Blender or whatever tools they made it in, they just made a duplicate, or they just like threw all the geometry stuff like for the frame and for the screen all into one buffer. And then I don't know if the frame is also indexed, but this index attribute here will tell you where to find within this buffer attribute, like where to find the vertices and the UVs and stuff for this geometry. These are the indices into these attributes. So we did expect it to be here, I'll pull up Excalidraw. So this front screen mesh is, you know, a quadrilateral, but it's drawn as two triangles. And the way that you would draw these using indexed geometry is, you know, this would be indexed like this. And then I don't know if this is going to be, you know, like this might be 3, this might be 0, but for sake of demonstration, we'll just say that this is how it's laid out. So the way that you would draw this first triangle is it's drawn index 0, 1, and 2, and then for the second triangle, you know, maybe it's 0, 2, 3. Let me zoom out a little bit. So these are the indices into those position buffers or attribute and the UV attribute and the normal attribute. It says, you know, to find the position for this guy, look at index 1 or look at index 0. And, you know, I'm not going to worry about like, is this clockwise or is this clockwise, you know, whatever. That's not important here, but so this kind of makes sense. We'd expect to see 6 values here because we're drawing 2 triangles for that quad. And if you look at the index buffer here, you have a value of 6. So this is telling you to draw that first triangle, look at index 112, then look at index 111, and so on. So typically, to get the dimensions of this mesh, you would use a box geometry, or a box 3, which is a class from 3JS. And I think this thing actually has a bounding box already calculated. Maybe it's on the geometry. Yeah, this bounding box 3 here, but it doesn't take into consideration that it's calculating that bounding box from the entire attribute. It's not looking into the index and saying, oh, only calculate, you know, for these vertices here. So you can't do something like this. You can't make a box and then box has these set from methods. You can't do this, and I'll show you why. So we can actually put this on one line. Now, let's make a box helper. That way we can visualize the box. That's a new box 3 helper. I guess you pass in the box. And let's add it to the scene. Yeah, so this yellow box here is what it thinks is the box of the screen mesh. Now we aren't showing the screen mesh, but you can see it was just that white. Yeah, it's what's in the entire buffer geometry here. So it's bigger than it should be. But if you calculate the box based on these indices here, then we'll get the correct results. And I know this because I was playing around with it yesterday. But it would be cool to put this in a box. Like, imagine if this was coming from Amazon, or you ordered it online or whatever, and you opened the box, and out came your TV screen or your TV or your... This, to me, it looks more like a computer monitor. But we can't do this. Instead, we'll make a box 3, and then we'll get access to that index buffer. That's going to be screen mesh dot get buffer. Actually, can we get the index? Oh, I think it's on geometry. Yeah, get index. Let's see what that gives us. A buffer attribute. That makes sense because that's what it says here. Well, we need to loop over that index. So let's do that in a loop. So index has this count property, number of items in the buffer attribute. So this should be 6, and we can see it's 6 here. But you can't just like go from 0 to 6 because you need to access this. So 0 to 6 wouldn't make sense. You want to get at position 0, it's 112. At position 1, it's 111. So to do that, we know that it's a buffer geometry, or an attribute buffer. There's too much lingo, but it's a buffer attribute, and this buffer attribute has a get x, and you just pass in the index. And that's going to be the vertex index that we'll use as an index into these attributes where my cursor is here. Yeah. So on Mac, you can like make the cursor bigger by wiggling it around a lot. But we have the vertex index, and then we want to get the x, y, and z. This position attribute here is just a raw like data buffer of positions, but it's xyz, 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 and so on. But we know that this should be one of these values, so we're going to use that as an index into that buffer. And you would say x equals, actually we need to get the position attribute first. So to do that, you would get the screen mesh geometry.get attribute, and it's called position. You'll take the position and you'll get the x at the index of I, or actually this is vertex index. Yeah, it's a vector 3s. Yeah, it's interesting they do it like that, because you could also do that whole idea of like, is it an array of structs or is it a struct of arrays? And I haven't really thought about like what the benefit is of laying it out in either way, but I think, you know, you use a lot of 3JS like CPU side, so it probably makes sense to lay it out in this format. So we got the x, and we need the y, and we need the z. What's it saying here? Oh, it could be null. Yeah, so if it's not an index geometry, then this is null, I believe. So again, we'll just throw an error if index is null. We can even do that. Well, we'll do that here for now, but you can imagine like we should probably do all our checks before we do any other setup. So moving all these pieces here that throw errors, we probably want to do that first thing. Make sure everything is properly formatted before we create the scene and process it and stuff. Process the mesh and all that. But I'll clean that up later. So if the index is null, then we expected a index geometry, but we didn't get one. So we'll just throw a new error. Expected screen mesh geometry to be indexed. So down here, which it should say, yeah, its index is not null. We know that it is well defined, or not null, I guess. But then you would take your box, let's move the box closer down here, and you would expand it by these points. So expand by point, and this takes a vector 3, so we need to make a vector 3. We'll just call it point. Haven't made that yet, but let's do that now so we get autocomplete. Bring that in, and we'll set it by these x, y, and z. And then set returns it returns the vector 3 back, so you can do like chaining on it, but you know, it's a reference at this point, so it sets the point and it returns the point. So let's visualize this box. So box 3 helper, it's our box. Put it back in the scene. Oh, gotta new it. Okay, what's broken? Probably had a infinite loop somewhere. Yeah, get rid of that. Let's see, that's under localhost. Yeah, something's broken here. I think it's frozen. Oh, yeah, right here. This needs to be I less than. Okay, let me kill the server. We'll bring it back up. Okay, there we go. And then, can you see the box? You can. It's very hard to see it, but that yellow line there is the box. And it looks like it's just a flat plane, and it is, and it should be. But let's see if we can change the material of the box. Yeah, the color here. Let's say that it's red. So now we see a red line. Barely. Right there where my mouse is at. So now we're getting the correct size of the box. Now that we did that, we can use box.getCenter, and it takes a target. So we'll need to make a center. Yeah, it's very small. I think it's because it's using GL lines, but yeah, it's right there. So we need a center and we need a size. Well, we'll get the center and then we'll get the size and put that into these targets. And now down here where we create the video texture here, this plane, now we can use the size. And then let's make it visible again. So it's offset. Let's put it back at the origin. But now we need to position it, you know, based on this position. So that's really easy to do. You just take the position and then we'll put it at the center. Oh, we need to copy it. And there we go. So now I'm on a little TV screen. Oh. Let me hide the webcam there. So, yeah, and I'd expect this little like bevel here too. Like on a real TV, you know, it is kind of beveled right there, I believe. But the one last thing to do is to set this size here, this width and height, to be based on the size here. So we have the width. We can just pass in size.x here and size.y. Now we don't even have to use this, but because this thing is so small, oh, I need a comma here. It's not going to look like any, yeah, it looks super pixelated because it's so small. And you can see, you can't tell, but I'm making it so you can see the webcam where I was before, but yeah, it is setting the size of the webcam too. So that's probably why the video got messed up earlier. But this needs to be like a really big number. Yeah, it looks a little bit better. Let's even go higher than that. Because if we look at the size, I don't even think these are values of, like, I think they're less than 1. Yeah, really, really small values. Factor is, what did I say, 1,000? It still looks kind of stretched out though, but it's hard to tell. It is definitely a little pixely. It might be. Yeah, Pikmin 3 today's report. Which is a game that I always wanted to play, but never got around to it. Yeah, pretty good. It's just a mix of music from like the Wii era. So now let me move this back here. So I kind of want this to be like whole numbers. Let's make this an object. Video size. And then we'll spread that here. Well, let's just do this. That way we can pass it in here. We'll call it constraints. How did you get into 3D graphics? Anyway, I had a job where they wanted to do custom designs on grills, like these kind of grills. Like this. So this was for a company that did whole house fans and like ventilation systems and stuff like this. And they wanted like a 3D model or something of that, and they wanted to be able to pass in like a stencil where you could apply that stencil to imagine like a let's see. I already have it open here. So when this comes off the like production line or whatever, it's just a flat like slab, and then they had a tool or whatever where you could like cut out your own shape of this. So they wanted to be able to like visualize that on the website and stuff in 3D. So that's kind of where it all started. And then my last job was again with like 3JS, and we were doing like modeling like load distribution across like a structure and stuff. So I had some experience doing it like that, and that's kind of the story. Now I just like to play around with it as a hobby, but I think it's a good practice. Like if I ever get a job or whatever, it will probably be 3D stuff, and probably 3D stuff in the browser. So it's funny, like I think about now how I would have done those projects differently, and you know, we just got done like doing stencil buffer stuff, and that grill project I would probably use a stencil buffer to do like the masking of the like shapes and stuff. I can probably show this on stream. This was the website, and it's not using any of the code that I wrote, unfortunately. Grill designer. Yeah, so here it is. Like they're still using a 2D representation of the grill. So it never really took flight, but that's typically what happens with small companies that, you know, try to do this new, exciting, cool thing. It's like, well, that takes a lot of time and it takes a lot of expertise. And And not to say anything bad about them, but it felt like they didn't know what they were doing, and I didn't know what I was doing either. So anyway, um, what I wanted to do was make this video constraints, and I believe this has a type that we can bring in, media track constraints, but it should be at video. Okay, media track constraints. I never knew what I'm doing, but I work it out. Yeah, there's a lot of learning on the job, in my experience. And I think that's a good thing because you want your employees to, be excited about what they're working on and go out of their way to figure something out. Unless they're just like, hey, chat GPT, how do I do this or whatever. That's what I don't like. I think the fun part about it, and a lot of the fun I had on those projects was, doing the research and discovering the new stuff, and there was like a passion behind it. What was this called? Media. Can I grab this from this buffer? Yes, I can. Look at that. I can just grab it from the pop-up. Yeah, so that looks good. But I want these to be whole numbers. So this is some float, but we can round it. Because these are in pixels, so it just makes sense that we round it down to the nearest pixel. And if I see, look at that, it even flipped. I'm gonna leave this down here too. Yeah, this whole stream will have a bunch of weird webcam stuff going on, but that's pretty cool. So that's what I wanted to accomplish today. I'm surprised it all worked out. I didn't forget any of it. So like a lot of these streams, I like to prepare them, just so that, you can expect that we'll make something and we'll get the job done. Yeah, GPT enabled people without the research skill, but it's also definitely much quicker. Exactly. Yeah, it has its purpose for sure. Like I used it all the time when I can't remember how to do certain things. Like I can't remember, do I call it this way, or what's the, super simple little algorithm that I can never recall and I don't want to derive it and all that. You just ask Chat GPT about it and it'll figure it out for you all. So I guess, yeah, I was saying that these are prepared streams a little bit because, typically the night before, I'll just like say, okay, this is what I want to stream, and I want to have a game plan of how we're going to accomplish that. So the night before, I typically, I'll flesh it out a little bit, and I'll say, okay, I know enough, I'm good to go, and then that's when I present it on stream. Yeah, I think that knowing where to find the information is a lot more valuable than memorizing it. So that always bothered me in school, was like, memorization is not learning. Learning just comes from doing something, failing to do something correctly, or doing it enough that it's just becomes second nature. I don't even know if I'd call that learning, but being able to find the information is what's valuable. So there's no point in memorizing anything. I mean, if you want to memorize stuff that you do all the time, well, that will just come naturally. Like at the beginning of the stream when we set up that boilerplate, we do this in all the time, so I know how to do it. I'm pretty familiar with it. And, the argument could be made that the stuff that you do all the time could be automated. So, why hold it in your memory when you could just automate that stuff? All that boilerplate, there's no sense in memorizing it. So, you know, if somebody says somebody's smart, well, either they're just done something so many times they have a lot of experience in it or practice in it, or what's the other one? Like they're just good at memorizing stuff. So the whole idea with this is that rather than showing the webcam stuff, and we might show it in a separate scene that we are going to now render to a render target, we're going to use that render target texture instead of this webcam. So let me close the window real quick because they're doing yard work again. I'll be right back. So we can get that rolling. That'll be pretty easy, I assume. We could probably just make a separate scene with a box in it and then render this video texture onto that box. Head to a meeting. Okay, thanks for dropping by and chatting. I'll see you in the future, probably in Slug Bubby's stream later today or something. Good luck. See ya. So let's make a render target. And it's nice to have these examples because I can just refer to them if I don't remember how I did something. Let's pull this up for reference. Let's make a render target scene. So that's its own separate scene, and in that scene we're gonna add probably just a box mesh. But this needs a box geometry, so make one of those. And that is box geometry. And then the box material is just going to be a mesh basic material, but the map is the video texture. So that means we have to create this thing in that attachment. Let's just skip this part for now. Okay, box geometry. Box material. There we go. Oh, I already have a box. So let's call this... this is the screen. Well, let's call this, I don't know if I'll leave it as a mesh, but we'll just call it mesh for now. I mean, I don't know if I'll leave it as a box, so let's call it mesh. And then I have that. We need to pass in box geometry, box material. Let's make a separate camera for this scene. Pull it back. Let's make a little helper function that takes a renderer. All that's going to do is render the render target scene. with the render target camera. I guess we'll call this target scene. No, I don't like that. What should we call this? Render. I don't know, we'll call it that for now. Okay, so if we jump down here, and we end this loop, let's just render mesh. So we'll turn this off, and then we'll render the mesh with the renderer. So now this is our new updated, well, this is what we're gonna render to the target, and this is what we're gonna show on the screen. So let's put the video texture back on, and to do that, this will be the box geometry. And then we'll take the render target scene. We'll add this mesh. We haven't made it yet, so let's mesh. Oh, I have it down here. All right, there I am. We don't need to add it here. We just need to make the scene. And yeah, we don't need to make this, or this, or this. So if I pass in the camera, well, let's move this on an axis. So we'll create an axis. We'll normalize it. This is our axis, and then let's go like 3 units. Oh, and then we need to look at the center of the scene again. That's scene. Well, that's gonna be, yeah, scene. There we go. So now I'm on a box. But we're going to render what you see here in the canvas at the moment is going to get rendered to that render target. So we'll pull up the render target example again. That's down below, down here. So we'll save the last render target, and then we'll set the render target to be the render target, I suppose. Now we render. That's just the render helper that we have, but I think that's a little bit too much, so we'll just grab this and get, well, we're gonna get rid of that, but I'll do that in a second. So I'll render to that target, and then we'll set it back to the last render target, like that, and then we'll render the scene like normal. But I want to make sure that I do this set size thingy. Okay, where's size? Oh, we get the size there. Okay, so render dot get size. We're gonna put it in size, but we need to make that. think that's a vector 2, so new vector 2. It's this, the dimensions of the renderer. Let's bring that in. Okay, so this mesh here, its map will be, or no, this, let me think. Yeah, maybe I need to make that plane mesh again. So we'll call that screen, new plane geometry. Oh, that's the geometry. The width of that thing is width and height, const, screen, material. Basic material, but the map here is going to be the render target texture. Render target dot texture. And then we need to make sure that, yeah, this is the render. We need to make sure that this gets added. So this can actually be done up here. Same with this. Render target scene, we add that. Okay, now I need to position this plane geometry. So I do need to save it to a variable. What did I say? Plane dot position dot set dot copy. This is not needed. Okay, I don't see it. Let's do some debugging. Color. Yeah, where is it? Oh, I didn't add it to the scene. Okay, there it is. And it's flipped upside down, but now we're rendering the... This is cool. I don't know why it's upside down, though. But the video... Yeah, you can tell what's going on. The webcam capture, whatever, is rendered onto that cube as a map into its material. We're adding that cube to the render target scene. That render target scene's texture is being used as a map on that screen here. And then that screen mesh is being positioned where the TV screen is. So let's make a more, let's see, box geometry. Let's try a different geometry. Like, what happens if we put a sphere here? Oh, I gotta import it. Got a big head. And I'm upside down. I don't know why I'm upside down. Which is funny. But now, you know, you can do things like, we'll take the mesh here, and we don't have a reference to it. But instead of creating this geometry here, we don't have to do that. So we can easily get a reference to this thing. The only thing that needs to be created here is that material. But what we can also do is set the material up here. Or we'll just create it. And then here, we'll take that material and set its map to be the video texture. And like, still gonna add it to the scene down below. Like that. So everything's still the same. Now we have a reference to this that we can use in the render loop. So we can take that and we can rotate it along the Y. And then how much do we want to rotate? Probably some factor of math.pi, so maybe like this will rotate it very slowly, but not too slowly, I hope. Yes, that's along the x-axis. Let's try the Z. I wanted to rotate it like, oh, you can't see me very well anymore. But that's along the axis that's straight into the screen, like the computer screen. Oh, I know why. It's because of the camera that got moved. Yeah, something like that. It's so weird. But it is kind of fun to play with. And it doesn't really wrap around that sphere geometry very well. So this is the Josh channel. So, maybe one day we'll get syndicated, or whatever the word is, on actual television. This is what it would look like if you brought your TV to some neighborhood with a pond and it was floating in space and you tuned into the Josh channel. Kind of like the box geometry. Oh, too close. Then let's bring it up off the Y by just a tad. Oh, okay, so this is... Should this be negative? I don't know, this is kind of strange. Well, the video itself is upside down too. So I'm not sure what's going on there. I mean, I could easily scale this thing. Let's see, where is that? Like this should put it upright. Yeah. But then I have to remember to put in negative values for this. So these are all like numbers that you play around with and tweak and stuff. Okay, let's put this to 1. I kind of want to get the TV screen Like, it would be nice if it was centered like that. Uh, so I think here where we do the camera for the main scene. Where's the camera? Yeah, this needs to be organized for sure. Yeah, where's that camera? Don't need that. Don't need that. This camera, what was I gonna do? Totally forgot what I was doing. Oh yeah, we need to look at, now that we have the center position of the screen mesh down here, we're gonna look at center. Yeah, so it is up, so we need to move the camera up a little bit. So we need to translate it. Where do we translate it? Right here. So we probably reuse our axis here. Axis, and then let's just do like 3 units, but I want to move, yeah, that's fine. Okay, we're too low, so this needs to be positive. Maybe like 3. Oh, too much. 2. We need to go very small amount. Yeah, that's fine. Then this needs to be like 1. Yeah, that's good. So now it's looking at the center, but what we did was we took the camera. What's this? A scallop. Took the camera that was looking at the screen and made it look at the center. As the center of the screen is here. Imagine that you're looking at the screen like this. And the camera got pulled back by 1 unit and then up. Or like this vector here is this axis vector. And then it doesn't look at, right now it's looking this way, but then when you call dot look at, to look at the center, then it, you know, tilts the camera down to look at the center here. And we didn't put the camera at the center because the center of this thing is here, but I believe 0, 0 is right here. So we should probably do, or I'll probably do this, is center it and then pull it back up and then look at. Because otherwise you're pulling it like along this axis, you're translating it along like, it's originally at 0, 0, so you're translating it from 0, 0 to this new axis, or to this new location here. But I think it looks pretty good the way that it was a moment ago. Alright, that looks sweet. That looks cool. Now the question is like, what should we put in this scene? For these examples and demonstrations and stuff, I like to make them a little bit silly. I mean, this is kind of silly here, but it would be funny to make like some other kind of scene with more in it, more things involved. let's see. Yeah, let me look at my notes, make sure that I didn't miss anything. Okay, just on the other monitor here, so make sure you can still see me. So make sure we got everything, and then I'll summarize what we did, and then I'll call it finito. Yep, it all looks good. I don't think we're missing anything. Okay, so I'm gonna wrap it up. I'm gonna summarize, and then we'll end the stream. I don't know when I'll stream again, because I gotta work next Tuesday. So my next day off is I gotta work for a straight week, or a week straight. So I might not be streaming again until Thursday. But today we wanted to mess around with loading in a GLTF model, which we're doing here. So that's really easy to do. You just get a hold of a model, you load it, and call .load with it right here. Then you can add it to a scene, or you can render it on its own. But the model itself, Three.js has no, there's no way to know about what's in the model at runtime unless you run some kind of validation on it or parser on it, like you do with form inputs. Like if you're taking user input and processing it on the server. So same idea. So in order to get around that, you have to kind of confirm that you know what you're working with, and you do that by, this is an example of how you may do that. But we get a hold of that screen mesh, which is what we're displaying on right now. There was a white, so we look at the original model of this thing. There's nothing here that I don't care if you guys see it. There's no secret sauce or anything in here. Projects, graphics glossary, source, no, it's under public. Public, GLTFs, TV. So we got a hold of this white mesh, and we made it invisible because we were going to replace it with a different mesh. So you could, dispose of this thing, but just setting it visible is such a simple scene that you really don't have to bother with that much optimization. But we also need to get the size of that screen because we're going to replace it with that video, that mesh with the video on it here. But it's an indexed geometry, so you can't just call box.setFromObject on it right here. Because it doesn't know that this geometry is actually indexed. But we can do that ourselves. And you do that by looping over the index buffer and expanding that box by all the positions in that buffer that are referenced by the index buffer. Then you get its center, and you get its size, and then you're going to make a plane geometry. Where did I do that? Right here. That is the same size and uses a render target texture. We'll get that to in a moment, but make the plane geometry, size it to be the same size as that screen, and position it at the center of that screen. And then that render target texture here, we create a separate render target scene here. We just add one thing into the scene, which is this cube, what did I call it? Mesh right here. So it's just a box mesh, and down here where we have the video going, we set the map. Well, you create the video source, create the video texture, and set the materials map to that texture. So now the cube has that texture on all of its faces. That gets added into the render target scene. You render that scene onto that target in the render loop, and then you switch back to the main scene, which has that screen mesh set in such a way that that render target texture is applied to that screen mesh. So there's a lot of moving parts, but hopefully that makes sense. And that's all there is to it. I think this is a lot more interesting of an example than this here, because this you have no idea what's going on. This is more exciting, but you assume that the user has a webcam or some kind of video feed or something. So I might refactor this in such a way that you don't necessarily need a web camera to look at this example. That's it. So if you're still around, thanks for tuning in. Like I said, I'll probably stream again in a week because I gotta work on Tuesday. So next week it probably will be Thursday and Saturday. I'm not sure what I'll stream. Might stream a game or something, might take a break from graphics programming. But I haven't decided yet. There might be something that catches my interest. So now I'm always on the lookout for things that I can stream, what would make an interesting topic. Yeah, so I'll see you then. Take care and goodbye. Have a good day and have a good night.